Stepping into the era of technology and mechanization, global agriculture is advancing at an unprecedented pace. The emergence of autonomous machines, intelligent data systems, and artificial intelligence has transformed traditional farming labor into a seamless operation of precision and efficiency, reducing human effort, boosting productivity by dozens of times, and bringing home over 9 billion tons of crops from the earth each year. Right now, join us as we enter the grand cycle of mechanization on a planetary scale, where mechanical power and human intelligence unite to create the most extraordinary achievements of modern agriculture. Gliding smoothly between the hazelnut rows, this intelligent harvester unleashes dozens of high-speed rotating brushes, creating powerful air currents that feed into a giant suction hose, swallowing up a carpet of nuts, dry leaves, and loose soil from the ground. Unlike almonds or walnuts that require vigorous shaking from tree shakers, ripe hazelnuts naturally fall in unison during a brief 2 to 3 week autumn window. Yet, that fleeting moment is also their greatest vulnerability. Just one untimely rainstorm can turn a golden harvest into a soggy, moldy disaster. The arrival of this harvesting machine has completely solved the race against time, becoming a true savior for farmers in Turkey, Italy, and the United States, helping them secure millions of tons of hazelnuts each year. Once the entire mixture is drawn into the machine's body, massive fans and rotating drums generate a man-made whirlwind. Dry leaves, dust, and light debris are blown away, while the heavy hazelnuts drop neatly into the storage bin behind. One pass of this machine replaces hundreds of manual workers, turning grueling labor into a compact, spectacular, and powerful display of mechanical precision. Combine harvesters, the towering giants that embody the speed and sheer power of modern agriculture, stand behind tens of millions of tons of barley harvested across Europe each year. Over 4 meters tall and more than 10 meters long, these machines wield razor-sharp blades and massive rotating reels that sweep through the golden fields, slicing through rows of barley in just a few swift passes. Inside, a compact yet relentless processing line comes to life. Powerful threshing drums spin at high speed to separate the grains from the heads. Vibrating sieves shake continuously to remove straw and impurities, while strong fans blow away husks and dust. After this perfectly synchronized motion, only the finest barley grains are conveyed into the storage tank, while the leftover straw is gently spread across the field, completing a flawless cycle in every turn of steel. With these colossal steel reapers, bringing in millions of tons of barley within just a few short weeks becomes effortless. Even when sudden fires break out under dry, scorching weather, they can still race against nature, harvesting, rescuing, and preserving the golden season before the flames can spread. What would happen if the irrigation canals, the lifelines of agriculture, were clogged with mud, waste, and weeds? In the worst-case scenario, an entire season's harvest could be lost. Water stops flowing, the fields crack and dry out, and crops wither under the sun. That's why specialized canal dredging machines were created, like steel arms ensuring that the agricultural bloodstream remains open and flowing. Among hundreds of designs today, the most common and efficient are hydraulic arm dredging machines mounted on tractors. With a flexible boom that can swivel 180 degrees, the rotating drum at the end scoops, stirs, and lifts mud from the canal bed while trimming weeds along the banks. Some advanced models from Hemos, Netherlands, and Greentech, Denmark, even feature pressure sensors and automatic leveling systems, allowing precise operation in narrow trenches. In countries like the Netherlands and Germany, large-scale versions equipped with giant rake buckets attached to hydraulic cranes are also popular. Dozens of curved steel tines work like a massive comb, scraping away sludge and debris without damaging the canal walls, keeping the water clean and free-flowing. Thanks to mechanical power, just a few hours of work by one of these machines can replace an entire day's labor by dozens of workers, restoring clogged waterways and helping the fields breathe again with the rhythm of the growing season. In fruit orchards growing mangoes, avocados, or longans across Europe and Latin America, GreenTech circular disc pruners are considered an ideal solution for small and medium-scale farms. Equipped with multiple high-speed rotating steel saw blades, these systems precisely trim each canopy layer, allowing light and air to circulate freely between branches. The result is well-balanced tree growth, evenly ripened fruit, and a significant reduction in pests, something that manual pruning can hardly achieve. But for large-scale plantations in the United States, Brazil, or Australia, where each orchard row stretches for hundreds of meters, farmers prefer horizontal fan blade trimmers. Their wide cutting structure and blade speeds exceeding 2,000 rotations per minute enable the machine to trim both sides and the top of the canopy in a single pass. Compared to the disc-type models, which focus on precision, the fan blade trimmers excel in speed, productivity, and wide area coverage, making them the perfect fit for intensive farming regions where every minute of operation holds high economic value. Soaring over endless green cornfields across Iowa, Nebraska, and Kansas, the air tractor and thrush aircraft, the steel wings of American agriculture, have lifted the entire industry to new heights, where the sky itself becomes an extension of the farmer's hand. Flying just 3 to 5 meters above the ground, these planes precisely spray GPS-guided ribbons of pesticides and fertilizers, covering more than 16 million hectares of corn each year, with near-perfect uniformity. Inside the cockpit, a high-pressure spraying system works in harmony with sensors measuring wind, humidity, and flight speed, automatically adjusting the flow rate in real time to ensure every drop lands exactly where it's needed. No more, no less. With performance tens of times greater than ground-based spraying methods, these reapers of the sky have become a symbol of peak mechanization in 21st century agriculture. Yet alongside their extraordinary efficiency come debates that never fade. Drifting chemicals carried by the wind, high operational costs, risks to pilots, and the long-term environmental impact that continues to challenge even the most advanced form of aerial farming. Before the arrival of liquid manure spreaders like GEA, Noon, or Husky, applying organic fertilizer used to be one of the toughest and most dreaded tasks for farmers. Today, technology has completely transformed that picture. From manure pits more than 10 meters deep beneath livestock farms, high-capacity pumps draw the liquid fertilizer through high-pressure pipelines and send it straight into the machine's massive storage tank, with a capacity of up to 50,000 liters. In traditional centrifugal spreading systems, a hydraulic pump drives a fan rotating at 2,000 revolutions per minute, creating a powerful spray that covers up to 25 meters in width, ideal for dry fields and flat terrain. This mechanism is simple and fast, but still suffers from significant nutrient loss due to evaporation. Meanwhile, modern subsurface spreading systems use an 18-meter distribution arm that injects the fertilizer directly into the soil, delivering nutrients straight to the root zone. This innovation virtually eliminates nutrient loss, reduces odor, and maximizes absorption efficiency, a breakthrough now widely adopted across Europe, North America, and New Zealand. In just a few hours, one machine can cover more than 50 hectares of land, saving up to 90% of the time compared to traditional methods. With 4 massive steel claws capable of digging more than 2 meters deep and gripping root balls weighing several tons, these large-scale tree spades have turned the once daunting task of uprooting and replanting trees into a remarkably simple operation, achieving survival rates of over 98%. When the hydraulic steel blades simultaneously pierce the ground, they carve out a perfect conical root ball, preserving the soil's microstructure and the tree's natural moisture balance. Moments later, the machine gently lifts the entire tree and its root ball, rotates it to align with its original sun orientation, and lowers it into a newly prepared planting hole. Thanks to a synchronized system of pressure sensors, precise hydraulics, and a high-strength steel frame, the entire process, uprooting, transporting, and replanting, takes only a few minutes. This replaces the work of dozens of manual laborers and crude equipment, making the tree spade a true savior for urban forestry projects, parks, and the relocation of old, mature trees. Amid vast vineyards in California, France, and Italy, especially in spring and early summer when mold and mealybugs spread rapidly, air blast sprayers glide tirelessly between the rows. Equipped with 1,000 to 3,000 liter tanks and powerful rear fans, they turn pesticide solutions into a fine mist that penetrates deep between the leaves, coating both sides of the grape canopy, something manual spraying can hardly achieve. In modern models like the Twister S6, sensors and GPS automatically adjust pressure, airflow, and spray rate based on canopy density, reducing chemical loss by up to 40% and saving thousands of liters of solution each season. In just a few hours, a single air blast sprayer can cover dozens of hectares, becoming the indispensable steel assistant of modern vineyards. Automated weeding machines powered by cameras and artificial intelligence are transforming the way Americans care for fields of lettuce, spinach, and kale. Equipped with high-resolution cameras that constantly scan the ground, the AI can distinguish each crop and weed with centimeter-level precision. Once a weed is detected, hydraulic blades swiftly extend and cut around the base of the crop without harming its delicate leaves. All operations are synchronized through GPS and speed sensors, allowing the machine to adjust automatically to terrain and plant density. In just a few hours, dozens of hectares can be completely weed-free without any human labor. However, with a price tag of $350,000 to $500,000, these robot farmers remain a luxury dream for many small farms. In May, across the green tea hills of Shizuoka, Japan's tea capital, machines begin stretching black nets over rows of young tea plants. During 10 to 30 days of this shading period, sunlight is partially blocked, allowing the leaves to retain L-theanine and chlorophyll, the secret behind the jade green color and signature umami flavor of premium sencha, kabusecha, and matcha. When the shading ends, Valiant or Maruyama harvesters glide gently along the rows, trimming a layer of tender shoots just a few millimeters thick. Built-in fans and conveyors collect the leaves into mesh bags, while GPS sensors automatically adjust cutting height and speed to capture only the finest parts. In just a few days, technology and tradition unite to create Shizuoka's perfectly timed tea season, where every leaf preserves the pure umami essence of the earth and sky. In Germany, the United States, and the Czech Republic, the world's great beer workshops, The once labor-intensive harvest, which used to require hundreds of workers climbing trellises to cut vines by hand, has now been transformed by massive hop harvesting machines operating with near-perfect precision. From a cabin level with the canopy, the operator grips the hop vine, cuts it from the trellis, and feeds it directly onto a conveyor belt. Inside, hundreds of rotating metal fingers swiftly strip the cones from leaves and stems, blowing the waste aside while the heavy, oil-rich hop cones drop neatly into collection bins. Each machine can process over 1 hectare of hops per hour, the equivalent of about 150 human workers. In an industry producing more than 190 billion liters of beer annually and consuming hundreds of thousands of tons of hops, these harvesters are more than just machines. They are the backbone of the beer world, where steel and engineering keep the flavor of humanity endlessly flowing. Flying just a few meters above the fields, agricultural pilots turn farming into one of the most daring and precision-driven professions in the world. With high-capacity nozzles mounted under its wings, a single agricultural aircraft can treat 300 to 600 hectares in a single day, achieving speeds tens of times faster than ground-based tractors or manual spraying. This massive efficiency has turned crop-dusting planes into a strategic weapon against plant diseases. In large-scale farming regions, especially industrial banana plantations in Ecuador, Costa Rica, and Colombia, these aircraft are nearly indispensable for combating deadly outbreaks such as black sigatoka, a fungus that can slash yields by up to 50% if left unchecked. Yet, alongside their undeniable effectiveness, aerial spraying also triggers major controversy. With just one strong gust of wind, chemicals can drift for kilometers, raising risks of water contamination and health concerns for nearby communities. A machine that can literally mesmerize you, that is the stone burrier, a powerhouse that transforms entire fields filled with rocks into smooth, level soil in the blink of an eye. The working mechanism of the stone burrier is based on a high-speed rotating shaft equipped with sharp blades. As it moves forward, this shaft breaks up the topsoil, crushes and filters it, while pushing stones, weeds, and plant residues deep beneath the surface. On top, only a fine, fluffy, and level soil layer remains, the perfect environment for sowing and planting. This machine is especially popular in Europe, particularly in Italy, Spain, and France, regions with rocky terrain and soils used for vineyards, olive groves, and vegetable cultivation. Beyond Europe, it has also been adopted in high-tech agriculture in Japan and China, as well as in urban landscaping projects across Asia. Picture a giant iron plow carving perfect lines across the field, as if sketching geometry onto the soil itself. This implement is pulled by a tractor with a large V-shaped metal mold mounted at the back. As it moves forward, the curved wings push soil from both sides toward the center, compressing and shaping it into straight ridges with uniform height and width. This mechanism not only loosens the soil, improves drainage, and maintains moisture around the roots, but also creates the ideal environment for crops that require raised beds such as potatoes, sweet potatoes, sugarcane, corn, and various vegetables. This modern transformer machine is an exceptionally effective solution, designed specifically for orchards and widely used in major fruit-producing countries, such as Brazil, the United States, Spain, Italy, and Australia. Its operating mechanism is based on a powerful spraying system mounted on a massive U-shaped frame with a tank capacity of up to 4,000 liters. As the machine moves along the rows of trees, each spray boom can be adjusted in pressure and angle to release a fine mist that coats the foliage evenly on both sides. The multi-level spray design ensures maximum coverage from the base to the top, reaching even the inner branches that are nearly impossible to treat manually. Thanks to its ability to treat multiple rows simultaneously, the machine's efficiency far surpasses that of smaller tractor-mounted sprayers or handheld units. From that point on, orchards of oranges, apples, mandarins, or grapes no longer have to fear the rapid spread of pests and diseases, as they are cared for evenly, with less time and labor. Of course, owning such advanced technology comes at a price, around $18,000 to $20,000 US. Aeroponic potatoes are one of the greatest breakthroughs in modern agriculture. In this system, the roots and tubers do not grow in soil, but are suspended in the air inside tightly controlled chambers. Ultra-fine nozzles continuously spray nutrient mist directly onto the roots, providing all the water and minerals required. As a result, these seed potatoes are usually ready for harvest after 8 to 10 weeks, which is twice as fast as conventional cultivation. That is why, in a well-managed aeroponic facility, yields can reach 70 to 80 tons of seed potatoes per hectare per cycle, ensuring a stable supply and high quality for commercial production. However, this technology also has some drawbacks. The initial investment cost is very high, requiring misting systems, electricity, and climate-controlled greenhouses. Moreover, the plants depend entirely on the system. Any power outage or technical malfunction can put the entire crop at risk. Despite these challenges, the economic benefits are remarkable. Farmers and enterprises can recover their investment quickly, thanks to the much higher number of seed tubers, while also reducing the risk of diseases compared to conventional cultivation. This is why aeroponics is rapidly expanding in India, China, Kenya, and many European countries, becoming a strategic solution to secure clean seed potatoes and strengthen global food security. So what do you think about this method? Gone are the days of gathering straw by hand or stacking bundles onto horse-drawn carts, a back-breaking job that consumed countless hours. Today, across vast modern fields stretching to the horizon, massive tractors work side by side with JCB telehandlers, replacing human labor with raw power and precision. The telehandler operates through a hydraulic boom that can extend outward and upward, fitted with clamps or specialized forks to grip, lift, and move bales, weighing hundreds of kilograms. Its extended reach allows it to stack straw bales high onto trailers or into storage barns, something ordinary forklifts could never achieve. Once loaded onto trucks, tons of straw bales are transported back to farms and storage facilities, where they are preserved as valuable feed, bedding, or even biofuel. Across Europe and the United States, the JCB telehandler has become the farmer's #1 assistant during the bountiful harvest season. Have you ever seen anything like this before? The handheld rotary tiller is a unique and innovative invention that has brought a real revolution to small farms and medium-sized fields. With its compact design and an engine directly connected to the rotary blades, this machine can plow, till, and loosen the soil in a single pass. The sharp steel blades spin continuously, cutting through hard soil, breaking it into fine particles, and burying weeds, creating a flat, fluffy, oxygen-rich seedbed that is perfect for planting. Thanks to its flexibility and efficiency, it has earned the nickname Mini Mechanized Assistant for agriculture. It is especially popular in India, China, and many African countries, where farm sizes are moderate, but the demand for mechanization is very high. Born in Kagawa Prefecture, Japan, in the 1970s, the square watermelon was originally created simply to fit neatly inside small refrigerators. But over time, what began as a practical idea evolved into a famous agricultural souvenir, often given as a luxurious gift with a price tag reaching nearly $800 per fruit. However, defying nature comes at a cost. Square watermelons are usually harvested early to preserve their firm shape, which means the flesh inside is less red, the flavor bland, and the natural sweetness of a traditional watermelon lost. Countries like Russia, Brazil, and China have all tried cultivating square watermelons, but none managed to build the brand or sustain the value the way Japan has. Only in the land of the rising sun has this fruit maintained its prestige and luxury status. From that success, the Japanese went on to create even more whimsical variations. Heart-shaped melons, pyramid-shaped ones, and even watermelons bearing human faces. Still, the square watermelon remains the legend that sparked the global trend of turning fruit into works of art, a phenomenon that continues to amaze and fascinate the world. And like every extraordinary story, this one also has a beginning. Right now, let's step into the most unique watermelon fields on the planet, where the journey of this bizarre fruit first began. Everything begins with tiny seeds. But when it comes to square watermelons, farmers carefully select robust varieties, medium-sized fruits with thick rinds, so they can withstand the pressure of the mold during shaping. The seeds are soaked in warm water for several hours to stimulate germination, then sown into seedling trays filled with loose, nutrient-rich soil. Within 10 to 14 days, the first green sprouts emerge, developing into sturdy seedlings with 2 to 3 true leaves, the perfect time to transplant them into the field. Meticulous care during this nursery stage is crucial, as the strength of each seedling ultimately determines both the quality and the final shape of the square watermelon. But before those tiny seedlings can take root in their new home, the watermelon fields must be carefully prepared. First, to awaken the life hidden within the soil after the previous harvest, plowing machines are brought in. Their sharp steel blades churn deep into the ground, turning over heavy clumps of earth and breaking apart hardened layers. This process not only loosens the soil, but also mixes in organic residues, enriching its fertility. Once the soil is soft and airy, farmers shape raised beds about 1.5 to 2 meters wide and 20 to 30 centimeters high to prevent waterlogging. The tops are leveled flat, aligned neatly like the even folds of a well-laid agricultural fabric. Finally, a suitable dose of fertilizer, especially well-rotted organic matter combined with potassium and phosphorus-rich NPK, is added to fuel the vigorous growth of young plants. This becomes the very foundation for the birth of those extraordinary square watermelons. One secret to boosting yield while reducing labor is the use of agricultural mulch. In modern farming, especially with high-value crops like watermelon, mulching has become an indispensable companion for farmers. A thin plastic film spread flat across the raised beds helps retain soil moisture, suppress weeds, reduce erosion, and maintain warmth during chilly days. More importantly, it creates a barrier between the fruit and the soil, minimizing soil-borne diseases and keeping the melons clean. Still, mulching is not mandatory. Depending on climate, soil conditions, and investment capacity, farmers may choose to use it or not. However, for square watermelons, where shape and quality are paramount, mulching is almost essential. And once everything is ready to welcome new life, the young seedlings are finally transplanted into the field. The golden spacing for watermelon growth is 60 to 70 centimeters between plants, with about 2 meters between rows. This density provides enough room for the vines to spread while ensuring good airflow to reduce pests and diseases. After transplanting, the soil around the base is gently pressed to secure the seedlings in place. In the first few days, small covers or white plastic sheets may be temporarily set up to shield the young plants from strong winds and harsh sunlight. Once the seedlings take root, the real care begins. Watermelon is a crop that loves water but is extremely sensitive to flooding. Farmers must water regularly, keeping the soil evenly moist, especially during the rapid fruit development stage. Drip irrigation or sprinkler systems are often used to ensure water is distributed evenly. In addition to irrigation, fertilization is applied in several stages. Nitrogen is provided early on to stimulate leaf and stem growth, followed by potassium to strengthen the rind and improve durability. At the same time, farmers prune the vines, keeping only 1 or 2 main branches to focus nutrients, and selectively remove poor quality fruits, leaving only the most promising ones to grow. About 30 to 40 days after being transplanted into the field, the plants begin to bear fruit. When the young melons grow to about the size of a fist, roughly 6 to 10 centimeters in diameter, that is the perfect moment to place them into the square molds. Farmers carefully slip each fruit into a transparent box made of hard plastic or acrylic glass. From then on, the melon will gradually expand, forced into the shape of a cube. For the next 2 to 3 weeks, farmers must monitor them closely, wiping away condensation from the mold walls, adjusting the position of the fruit, and ensuring it develops evenly. This is the stage that determines the value of the watermelon. Will it be sold for just a few dollars, like any ordinary melon, or become a rare square watermelon worth hundreds of dollars, an object of global fascination and desire? Yet even the smallest mistake could cause the fruit to crack or deform, turning weeks of effort into nothing. That's why farmers must stay vigilant throughout the entire shaping process. Inside their transparent square molds, the watermelons continue to grow day by day until, around 80 to 100 days, they are finally ready for harvest. With only about 200 to 400 produced each year, this limited edition crop is harvested entirely by hand. Farmers gently remove the mold and cut the stem from the vine. Unlike ordinary watermelons, which are picked at peak ripeness, square watermelons are harvested earlier to keep their rinds firm and their shape stable, which is why they are prized mainly for display rather than eating. After harvest, each fruit is carefully cleaned, labeled with certification, and packed into an individual box. The premium ones are even placed in elegant wooden cases, turning them into luxury gifts at high-end supermarkets in Japan or exclusive exports to demanding markets abroad. But that's not the only extraordinary fruit in the land of the rising sun. Alongside the famous square watermelons, Japan also boasts another treasure, the Densuke black watermelon, a fruit that stuns with its striking appearance and unbelievable price tag. At first glance, the Densuke is enough to make anyone stop in their tracks. Unlike the familiar green-striped rind, it wears a jet-black skin, sleek and glossy like a polished lacquer finish. This absolute minimalism creates an aura of mystery and allure, with the highest recorded price reaching over 6,000 USD for a single watermelon at an auction in Hokkaido in 2008. Densuke set a world record. Yes, you heard that right. one watermelon costing as much as a small car. So, what secret makes this fruit so incredibly luxurious? Unlike ordinary watermelons, each densuke vine is allowed to bear only a single fruit, so that every bit of nutrition is concentrated into growing that one melon. Not every soil is suitable either. Only select fields in Hokkaido with their unique mineral composition can meet the requirements. Before every planting season, farmers test the soil, adjust its pH, and even rotate crops to preserve fertility. What's more, most black watermelons are cultivated inside greenhouses to control the microclimate, ensuring stable temperature and humidity throughout Hokkaido's short growing season. Every step of care, from pollination and pruning to shielding the fruit from sun and rain, is carried out entirely by hand. Farmers even place a layer of straw beneath each melon to keep the rind perfectly smooth and unblemished. By harvest time, only those fruits that meet the strictest standards, flawless round shape, balanced size, and a pristine, mirror-like black sheen, are awarded the prestigious densuke label. The rest are immediately discarded. After being harvested from the greenhouse, the melons are immediately brought to the processing facility. Here, each fruit is carefully wiped with a soft cloth to remove any dust, while the rind is polished until the black surface gleams like a lacquered finish. Though seemingly minor, this step is crucial. A single scratch or irregular spot is enough to disqualify the fruit from carrying the prestigious densuke name. Once approved, every black watermelon is labeled with certification and placed in an individual box, ready to be delivered to luxury supermarkets or taken to exclusive auctions in Hokkaido, where their value can skyrocket many times over. There, each densuke watermelon is no longer seen as just a fruit, but as a true symbol of refinement and prestige, coveted like a genuine work of art. The Netherlands and Spain are the two true superpowers of greenhouse cucumber exports, supplying Europe with fresh cucumbers all year round. Meanwhile, Russia, Japan, and China operate vast greenhouse complexes that produce millions of tons annually, meeting massive domestic demand while also serving export markets. Compared to traditional open-field farming, greenhouse cucumbers stand out for their ability to be grown under precise control of temperature, humidity, and nutrients, resulting in uniform growth, perfectly straight, glossy green fruits with a crisp, refreshing taste. On the same land area, greenhouse cultivation can yield 6 to 10 times more cucumbers than traditional methods, thanks to vertical growing systems that maximize space and harness every ray of light. However, this comes at a price. Greenhouse cucumbers typically cost 2 to 3 times more than outdoor-grown ones, due to the heavy investment in infrastructure, technology, and energy. Every year, greenhouse cucumbers reach a staggering output of around 40 million tons, nearly half of the world's total supply, bringing in an estimated 27 billion USD for the high-tech agriculture industry. With their unmatched productivity and consistent quality, greenhouses are seen as the farming method of the future, paving the way for sustainable agriculture worldwide. Now, step with me inside these lush greenhouses, where miracles are crafted by diligent hands and the technology of tomorrow. To achieve a high survival rate and ensure uniform fruit quality, 90% of cucumber farms today choose to cultivate from seedlings germinated in modern nurseries. The first step in seedling production is preparing the substrate trays. These trays are typically 50 by 30 centimeters in size and divided into 40 to 60 evenly spaced cells. Inside each cell lies a layer of substrate made from coconut fiber, peat moss, or rock wool, materials that are lightweight, airy, and disease-free. On the tray surface, an automatic perforation system creates small holes about 1 to 2 centimeters deep, allowing the seeds to settle neatly. Alongside tray preparation, cucumber seeds are also carefully processed and meticulously selected. These seeds are taken from specially chosen cucumbers with high uniformity, firm shells, and completely free from pests, diseases, or cracks. In the sowing process, a vacuum system lifts each tiny seed, evenly distributes them along the conveyor, and drops them precisely into the pre-made holes in the substrate trays. Next, the conveyor carries the trays through a sprinkler system that simulates artificial rain. The water is applied in a fine, even layer, just enough to moisten the surface coating without causing waterlogging. This step is crucial to ensure a high germination rate. Finally, small sticks about 20 to 25 centimeters long are placed into each cell to guide the seedling's growth, helping them develop upright. The trays are then gathered and transferred to the nursery area for the next stage of care. In many high-tech farms, instead of direct seeding, cucumbers are cultivated from pre-nurtured seedlings. These healthy young plants, about 10 to 15 centimeters tall, are transferred into greenhouses using automated transplanting systems. This method increases survival rates, ensures uniform growth, saves time, and significantly shortens the production cycle. In modern nurseries, seedling trays are placed under strictly controlled environmental conditions to maximize survival rates. Temperatures are kept stable at 25 to 28 degrees Celsius, while humidity is maintained between 80 to 90% to create the perfect environment for germination and early growth. On cloudy days, specialized LED lights are switched on to provide supplemental photosynthetic illumination, ensuring seedlings maintain a steady growth rate. At the same time, irrigation and nutrient delivery systems are fully automated, supplying dissolved fertilizer solutions tailored to each growth stage. Thanks to desynchronized care, after just 3 to 4 weeks, the young plants reach heights of 15 to 20 centimeters, bearing 2 to 3 deep green true leaves, with evenly spread roots and sturdy stems supported by the guiding sticks placed earlier. Once they meet the required standards, all trays undergo a final inspection, where weak or uneven seedlings are removed. Afterward, the seedling trays are neatly packed, carefully arranged on conveyor lines, and moved into temporary storage. Here, humidity and temperature are kept stable to prevent transplant shock during transport. Finally, the trays are distributed to commercial greenhouses, ready to begin large-scale cultivation. Inside the greenhouse, healthy seedlings are carefully prepared by workers before being transplanted. Each young plant is gently placed into substrate bags or specialized growing racks, where planting holes have already been prepared. Immediately afterward, a drip irrigation system is connected directly to the base of each plant, ensuring precise delivery of water and nutrient solution. Cucumbers are not simply watered in the usual way, but nourished through a hydroponic drip system, with a precise formula of nitrogen, potassium, magnesium, and other micronutrients, often referred to as a nutritional cocktail. Thanks to this laboratory-like precision, the plants can grow so rapidly that they may stretch several centimeters overnight, leading Dutch farmers to joke that they can actually hear cucumbers growing. Because cucumbers grow so quickly, workers must frequently use tools to secure the growing tips, preventing the plants from spreading out of control. Overhead, trellis systems are installed along each row, with the stems clipped to the wires using small plastic fasteners to guide them upright. As the vines lengthen, they are carefully wrapped around the wires or lowered, creating infinite plants that can reach 10 to 12 meters and continue producing fruit without pause. Thanks to this technique, the cucumber rows stand neatly aligned like a vibrant green wall, maximizing light exposure and ventilation, and yielding straight, uniform, high-quality fruits. During the growth phase, cucumber greenhouses are monitored by advanced sensor systems that continuously track temperature, humidity, and CO2 levels. In daylight hours, additional CO2 is supplied to boost photosynthesis, which can raise yields by 20 to 30%. Yet even a 2 to 3 Celsius fluctuation or a shortfall of water can make the fruit bitter, so shades, fans, and misting systems are constantly adjusted automatically. Throughout the care process, workers regularly remove old leaves, diseased foliage, and unnecessary side shoots. This pruning improves light penetration and airflow, reducing the risk of fungal diseases. At the same time, nutrients are directed toward flowers and fruits, helping cucumbers grow straight, uniform, and of the highest quality. Cucumbers in greenhouses are vulnerable to pests, from aphids and thrips to spider mites. Instead of using chemical pesticides, farmers release beneficial insects, natural predators that hunt down these pests. At first glance, these tiny particles may look like pesticides, but in fact, they are living insects, tiny guardians released to protect the cucumbers. While cucumbers grown in open fields require bees and other insects for pollination to bear fruit, this is almost impossible inside greenhouses. For that reason, most greenhouse cucumber varieties are parthenocarpic, able to set fruit without pollination. Thanks to this trait, the plants produce reliably even in closed environments. Moreover, the cucumbers remain straight and smooth, free from curves or deformities. Thanks to the combination of smart monitoring technology and meticulous care, after about 30 to 40 days of planting, each cucumber vine in the greenhouse reaches peak performance, flowering simultaneously and entering a phase of steady harvest. At this stage, workers pick cucumbers every 2 to 3 days to ensure the fruits reach standard size, retain their crispness, and keep a deep green color. To guarantee premium quality, harvesting is done mostly by hand. Skilled workers walk along each row, using small knives or specialized scissors to gently cut the stems, then carefully place the fruits into crates or carts to avoid scratches. Once the carts are filled, the results of weeks of careful cultivation are immediately transported to processing facilities for sorting and packaging, where each cucumber is meticulously prepared before reaching consumers worldwide. But have you ever wondered what happens to cucumber plants once a harvest is completed? Cucumbers are short-cycle crops, producing for only a limited period before quickly declining. For this reason, once the final fruits are picked, the entire vines are cut down, collected, and sent for composting or recycled into organic fertilizer. This not only cleans and resets the greenhouse for the next planting cycle, but also helps close the loop of sustainable farming. Meanwhile, at the packing facility, freshly harvested cucumbers are placed onto an automated conveyor system and directed to different packaging zones. Here, each cucumber undergoes a visual inspection, with misshapen or scratched fruits removed, before passing through grading machines that sort them by size and weight into uniform groups. What sets greenhouse cucumbers apart from those grown outdoors is that they do not need to be washed before packaging. Because the entire growing process is strictly controlled, the plants never come into contact with soil, rainwater, or chemical pesticides. Even the workers responsible for plant care or harvesting must undergo strict disinfection procedures before entering the greenhouse. As a result, the cucumbers retain their natural waxy coating, a protective layer that preserves freshness and crispness throughout storage and transport. The selected cucumbers are then directed to be tray-packed, shrink-wrapped, or neatly placed in cartons, ready for labeling and shipping. Finally, once labeled, the boxes of cucumbers are neatly lined up on conveyors, Robotic arms automatically lift and stack them onto pallets, forming sturdy blocks of goods. Every pallet is standardized for easy transport and cold storage. From here, the cucumbers are ready to leave the facility, heading to supermarkets and dining tables around the world.